In the boundless expanse of the main asteroid belt, beyond the orbit of warlike Mars, lie dormant thousands, perhaps millions, of celestial bodies, remnants of the early solar system's genesis. Amidst this rocky chaos, dominated by small chunks of ice and stone, there are also true giants, objects capable of captivating the imagination. One of the most enigmatic inhabitants of this belt is the asteroid Psyche. Psyche stands out among its counterparts because it belongs to a rare class of metallic asteroids. Scientists hypothesize that its interior consists of iron and nickel, with trace amounts of stone. But the most intriguing aspect lies elsewhere. For decades, researchers of the celestial depths have suspected that Psyche is not just an asteroid, but possibly the exposed core of an ancient protoplanet that was never destined to become part of the planetary family. Is this truly the case? The early years of the solar system were an era of chaos and collisions. Myriad asteroids and comets hurtled through space, colliding, shattering, and merging under the influence of gravity. This is how planetesimals were born, the embryos of future planets, sometimes reaching kilometer sizes. These planetesimals continued their dance of collisions and mergers, forming increasingly larger bodies whose gravity attracted even more material. Some grew to the size of the Moon, becoming protoplanets. Not all protoplanets survived this cosmic crucible, but those that did came to dominate their regions and eventually transformed into the planets we know today. The surfaces of terrestrial planets, barely formed, were incandescent due to the relentless bombardment of smaller bodies. During this period, a crucial process known as differentiation occurred within the young planets. Heavier elements, such as metals, sank inward, forming the planet's cores, while lighter substances, silicates, remained closer to the surface. This process led to the formation of the layered structure of rocky planets and moons, with dense, metal-rich cores surrounded by a mantle of lighter material. Unfortunately, penetrating the depths of our own planet to confirm these theories is not yet possible. How can we reach Earth's core? Drilling a well 3,000 kilometers deep is a task that remains beyond our current capabilities. Therefore, scientists are forced to study the internal structure of planets using indirect methods, by measuring their gravitational field or analyzing seismic waves passing through their interiors. This is why the opportunity for direct study of a hypothetical core of an ancient planet or protoplanet represents immense scientific value. It would allow astronomers to gain a deeper understanding of the processes of planet formation and evolution. And it seems they have a chance to study something similar, an exposed planetary core. The asteroid Psyche might very well be such an object. Psyche was first catalogued in 1852 by Italian astronomer Annibale de Gasparis, who noticed a new, faint, moving spot of light in the sky. He decided to name it after the Greek goddess of the soul. It was only the 16th asteroid discovered. With an average diameter of 226 kilometers, Psyche is roughly 16 times smaller than the Moon. It orbits the Sun in the main asteroid belt, between the orbits of Mars and Jupiter, and is one of the most intriguing objects in this belt. It is the largest and most massive asteroid of the rare M type, where M stands for metallic. Of course, no one has yet approached Psyche to verify its metallic composition. However, astronomers are accustomed to obtaining necessary information using indirect methods. For instance, an asteroid's composition can be inferred from its density, which, in turn, can be calculated by knowing its mass and size. Scientists determine mass by observing the gravitational influence objects exert on each other. Psyche is massive enough to perturb the orbits of neighboring asteroids, and by measuring the extent of this influence, astronomers determine its mass. Determining its size is a more complex task. Early, approximate estimates of Psyche's size were obtained from its infrared emission. Visible light reflected by an asteroid doesn't always reveal its true dimensions. For example, a small but bright asteroid can reflect as much light as a large asteroid with a dark surface. Infrared emission circumvents this problem. When sunlight strikes an asteroid, it emits a portion back into space as infrared waves or heat. The amount of infrared radiation depends on the surface area, and thus the size of the asteroid. A larger asteroid emits more infrared light. Using the IRAS infrared satellite in the 1980s, scientists determined that Psyche's diameter was over 200 kilometers. These data were later refined using various methods. As a result, astronomers concluded that Psyche is indeed a large and dense asteroid, composed of approximately 95% metal. Since then, the idea of it being the core of a dead planet has become particularly popular. Interest in Psyche grew exponentially, and the world's top observatories were enlisted to seek further evidence. One of the key instruments that provided valuable insights into the asteroid Psyche was the Arecibo radio telescope. This giant telescope, unfortunately, ceased operations after its partial collapse in 2020. From the late 1980s, Arecibo was actively used for radar observations of Psyche, allowing scientists to determine its shape and assess its surface chemical composition. The radar method involves transmitting a radio signal to the asteroid and then analyzing the reflected radio waves. Each reflected signal carries unique characteristics, such as delay and amplitude, which depend on the features of the terrain. This enabled astronomers to measure the asteroid's shape and identify some of its characteristics. For instance, a 2015 study revealed the presence of at least 2 large craters, tens of kilometers in diameter. Radar observations also allow for determining the chemical composition of the asteroid's surface, as different materials reflect radio waves differently at various frequencies. Metals, such as iron and nickel, have higher reflectivity compared to stony rocks. Initial radar measurements showed that Psyche had twice the radar reflectivity of typical stony asteroids. It was later established that the asteroid's surface has a combined composition, blending metals and rock. This was confirmed by spectroscopic observations conducted by the Hubble and Spitzer space telescopes. The rocky areas could be remnants of an ancient mantle, analogous to Earth's mantle, or the result of numerous collisions with other asteroids. It is hypothesized that if Psyche is indeed an exposed core, the protoplanet it belonged to could have been comparable in size to Mars. However, its evolution was interrupted, possibly due to a collision with other protoplanets that destroyed its outer layers and exposed its metallic core. Over time, this core cooled and transformed into the asteroid that now resides in the asteroid belt. Beyond its scientific value, Psyche presents immense economic interest. This asteroid has been dubbed the gold mine of space, as it contains colossal reserves of iron, gold, platinum, and other valuable metals, whose value could vastly exceed that of the entire global economy. Psyche is an incredible source of resources, and when space mining technologies become available, it may become one of the primary targets for industrial development. However, recent studies suggest that initial estimates of Psyche might have been overstated. Perhaps the asteroid is not as rich in metals as previously thought, and the idea of its origin as the exposed core of a dead planet may also not be accurate. One of the key issues is the asteroid's density, which, according to the latest calculations, is significantly lower than expected for a massive piece of iron. Density estimates range from 3.4 to 4 g/cm superscript 3, whereas an iron-nickel core should be at least twice as dense. Thus, the metal content in Psyche could be between 30 and 60%, rather than 95%, as previously assumed. If Psyche is composed of metal, it would have high porosity. Porosity is a common characteristic of asteroids, exemplified by asteroid Bennu, which is half void. However, Psyche is significantly larger and more massive than Bennu, and studies of its surface indicate the presence of metal. In any case, Psyche's density is twice that of rocky asteroids of similar size. If Psyche were purely metallic, its porosity would have to be around 50%. However, a 2022 study suggests that the formation of a large metallic asteroid with high porosity is unlikely. Consequently, the asteroid likely contains a rocky component that lowers its density. This contradicts the dead planet core hypothesis. Nevertheless, Psyche remains an extremely interesting object for astronomers, and new estimates of its composition only fuel further interest in it. To ascertain the asteroid's true nature and test the hypothesis of its origin as the core of a failed planet, NASA plans to send the Psyche spacecraft to it. The launch of the spacecraft on a SpaceX Falcon Heavy rocket is scheduled for October 2023. Psyche will perform a gravity assist maneuver at Mars in 2026 and reach Psyche in 2029, after which it will orbit the asteroid for 2 years. The spacecraft's cameras will capture craters, rocks, and other surface details with high resolution. Additionally, the cameras will be equipped with spectral filters to determine the surface chemical composition, which will help establish whether the rocky material is remnants of a protoplanetary mantle or debris from other asteroids. Like an experienced explorer, the spacecraft will measure the asteroid's gravitational field with exquisite precision. By gradually lowering its orbit, it will fly over areas of Psyche varying in density. Even the slightest gravitational fluctuations, affecting the spacecraft's position and velocity, will be meticulously recorded, allowing scientists to peer inside this celestial body. By analyzing these minimal changes in gravity, astronomers hope to unlock the secret of Psyche's internal structure, whether it is a monolithic metallic core or a loose structure comprising numerous small fragments held together by gravitational force. In addition, Psyche is equipped with a magnetometer, an instrument on which scientists place particular hope. While the asteroid is unlikely to possess its own magnetic field, there is a possibility that Psyche, having once been the core of a failed planet, retained traces of its magnetic field within its rocks and metals. The discovery of these remnant magnetic fields would be compelling evidence that Psyche was indeed part of a protoplanet. In this scenario, astronomers will have a unique opportunity to study such an object and unveil the mysteries surrounding the formation and evolution of planets, mysteries that our own Earth might also conceal beneath its layers of rock.